Good evening, everyone. Geotechnical Engineering Part A Soil Mechanics. Let's review a very interesting example in seepage in soil beneath a concrete dam if the upstream and downstream water depths are provided. So, in this example, we have a concrete dam with upstream and downstream water level and a saturated soil layer beneath the concrete dam, and it just extended until we reach to an impermeable layer of soil. So by constructing the flow net and also isopotential line, which you can see in the figure, and we want to know what is the velocity at a point given A. So this is our soil beneath the concrete dam, and it's eventually reaches to impermeable layer of rock at the very bottom of the soil layer. So we want to calculate the water velocity at a given point like A, what you can see here over here. Mhm. If the information provided like hydraulic conductivity of the soil is given, which is K is equal to 8 times 10 to negative 4 meter per second, and also the porosity of soil layer is N is equal to 50% or zero point 0.5. So in approaching such problems, the very first thing we need to do is to just based off any reference calculate the jot down the seepage velocity formula. So V sub V stands for seepage velocity, which is K over eta times delta H over L. In this formula, V is seepage velocity based off feet per seconds. Our problem is in SI units, so it just turns to be in meter per seconds or centimeter in seconds. Likewise, hydraulic conductivity is again feet or meter per seconds or centimeter per seconds. Delta H is change in head of water, which travels from all the way from upstream to downstream. That's a feet or meter, and also the length or path which water travels. And eta is known in like N in soil mechanics, and that's the porosity of soil, which is provided to be 50%. So by knowing this, if we have a closer look to seepage velocity over here, you can easily see it's almost Darcy equation. So as you know, delta H over L stands for I, and I is nothing but the amount of that's a hydraulic gradients, and it just says how much the amount of tiredness of water when it travels from a upstream side to downstream side. And if you just replace eta by n, these are both stands for porosity but different signs. So we have already know what our n is, that's 50% or zero point 0.5. And if you just replace v sub v by v prime and then jot down the Darcy law in soil, which says velocity is equal to hydraulic conductivity times the hydraulic gradient of soil. That's Darcy law. If you replace Darcy's law in seepage velocity, you can easily see V sub V or V prime is nothing but Darcy law, which is velocity divided by eta or n, which is porosity of soil. So far we do know v prime in terms of equation is equal to k times I over the porosity of soil layer which is provided. So let's jump to the problem. First, we want to calculate what the velocity is, what is the multiplication of hydraulic conductivity times hydraulic gradient. Then after having this part, divide that by the porosity of soil to get the velocity at a given point A. So at the same time, we do know I is delta H over delta L. Hydraulic gradient is nothing, but how much is the amount of tiredness of water in water when it travels through the length of a specific amount of length in soil, which in our case that's a 10 and 10, which is 20 meters. So delta Hi is delta H total over number of drops. And if you keep a closer look to upstream and downstream, you can easily see delta H total is 80 meters minus 5 meters, which is 75. And for number of drops, if you just start from the very downstream and just climb each of these isopotential lines all the way to the upstream, we have 15 of those lines, including the upstream part. So that's 15, 75 over 15 gives us del- each of these head loss is equal to 5 meters. That's delta Hi. So if we want to calculate likewise hydraulic gradient for point A, so this is point A, you can easily see the distance is 10 plus 10, 20 meters, and delta H is just happen to be in the distance of three of these lines, so two spaces, like each of these spaces stands for 5 meters of delta Hi. So I at point A is equal to delta H over delta L. Delta H is 2 times delta Hi, as you can see in the figure, over the length, which is 2 times 10 meters. And if you do the math, it just gives you 2 cancel out from numerator and denominator. 5 over 10 is just zero point 0.5 in terms of hydraulic gradient at point A based off the figure provided. So as soon as we have I, we can simply multiply I in the hydraulic conductivity which is provided. So by having so is, and also V prime is Ki over N. N is also provided. So by having that, we can easily calculate the velocity at point A, which is V prime is equal to K times I. K is provided based off problem statement times I hydraulic gradient, which we already calculated that to be zero point 0.5 over porosity, which is 50%. And if you do the math, it just gives you 0.08 centimeters per second. That's the velocity at point A based off this figure. Thank you. We'll solve more problem in seepage in soil in next video. Goodbye.